right, hello and welcome to Bug Free Productions. Uh, haven't been on in a while, and things are probably going to be moving in a slightly different direction uh, with some of the channel and the videos I'll be posting. One of the big changes being that it's going to change from posting a scheduled time to more of a irregular time. Um, just to deal with, I'm still moving around quite a bit after starting my master's program and getting all that started. Feel free to say hello in the chat. Um, but, and this is kind of the first one in a while, so it might be a little bumpy. What I'm thinking we're going to do today is to do some Unity input type stuff. Uh, so we can do some certain other things with our input system. This one will focus more on a Mario Party style build and keeping our input settings across multiple scenes, making it a little bit easier for us to use our input and for players to move from one scene to the other. Um, as I mentioned, I'm going to change the format a little bit, so I'm going to probably be doing some live coding and then some explanation videos that'll probably start at the beginning. So I already have all this stuff open, so I'm going to go ahead and start the recording. All right. So hello and welcome to Bug Free Productions. We're looking at the Unity input system today. And as part of today, I have my scripts open over on this tab here. And we'll be looking at a couple things, including a game mode node, a game player node, a game manager singleton, and a player input collector. If you aren't an experienced programmer, don't worry too much about this sort of thing. What these mean, these are very abstract and simplified versions of some of these ideas. So it should be pretty easy to follow. First of all, we usually start in our Unity game inspector mode, and we just kind of look at some of the things here. So you'll see all these classes. We won't necessarily need these for the thing we're talking about today, which is our input management system. So Unity has a nice input system, has a really nice input system with the new input system. And you'll see here that as I move my arrow keys, it's pretty responsive. There's just a couple things to keep in mind, as is with everything when you're programming. With that, we'll probably go look at the hierarchy before we jump too much into code and just kind of walk through what I was thinking of as I developed this uh, little bit of code, which I'm sure other people have had similar solutions, but I kind of like this one. So if we look at this, we have a game mode node. So you can think of this as the game mode. So if you think of Mario Party, like the menu selection would be one node, is what I'm thinking is the logic behind this. So like anything that has controls in the scene that we're currently in is going to be our mode node, so to think. And then we have our game player node. So our mode is going to have so many inputs that can be assigned. So you'll see the player nodes, so many player nodes connect to a game mode node. And this is to allow, this was developed as in mind of my class. So in mind of the Unity development class, I wanted to keep a relatively simple and serializable reference style so that they could easily create their own nodes and inherit from these basic ones, but it would still have all the core functionality that never needs to be overwritten, which is actually probably a trickier part than actually just getting it to go from scene to scene. As you'll see here, But we have the game mode node. So this is the game mode execution that feeds back to the game mode singleton, which we'll cover in a minute. Game mode node, which is the input, has all the actions that a player's input will perform based on what node they are assigned. So this way you can develop asymmetric multiplayer pretty easily. You can still do very symmetric multiplayer and that sort of thing. And don't worry too much about this testable game object and or game player node and player move context. Basically what that is this is just my basic movement, the way I set up my movement type stuff, um, which you'll probably see if you go back and watch the racer videos. But that's that, and we're going to continue on to the next thing here, which is going to be our game object manager. So what our game object manager essentially is this is the manager that goes across persistently across all the scenes, holds our reference to our input that we get from our Unity, from Unity itself, its new input system. So basically all the input manager has to do is have an input manager. So player input manager, which is going to handle all of our stuff that's provided by Unity in the input system and allows us to keep track of the devices that are linked and the devices that are running, if they are in sync or if they drop off. And we can enable split screen if that's so your desire. I actually have a separate script, so I don't use this anymore, because enable split screen only works if you want to split it vertically. So vertically down into two halves, left and right. But if you want to split it top and bottom, you actually can't do that by default, so you have to do it by yourself. Um, which if you look up some of my racer ones, I think I have some of the bike race video, one of the bike race videos has a setting where I show how this script I made works and how it works with the events, which I probably also have in here. But yeah, on player join calls something else that works. Not part of this little walkthrough, but just worth mentioning. Game Manager Singleton script is a script that I actually made, and we can go look at that first. So we explain our singleton first, and then move into our player input and other things. If we hit play before doing that, I just want to point out that we also have, okay, so if we expand our do not destroy on load, the game manager is in here, and parented under the game manager is a single player persistent uh, clone, which is the player input for the actual, yeah, input for the device. And then we have single player input collector, which is my script. So player input you can add normally, and then input collector is something I developed specifically to be different. And we'll look at the game manager first, and then look at the input collector, and then we'll move on to the nodes. So if we start with the game management, game manager singleton, um, so looking at game manager singleton, let's zoom out for a second and go up to the top. So remember to always comment your code, and part of the reason I commented this one a little more heavily than you'll see in some of my bike race videos is just because I didn't want, eventually I'll probably share this um, with the course as like a clone of this project. I'll share a clone of this project with the course, and that'll be public, and then I'll probably put that up on one of these video links or something. And then you can go ahead and get that sort of thing. So you could fork that and make your own little game. Once you understand how it works, also going to go ahead and hopefully try and package some of this for the Unity store so that it can be imported gotten through those types of means, and we got a little bit of logic. I just separated this into party, so you might be wondering if you watched other videos, why don't I put this in tools? Well, Bug Free Productions is my company. Um, Dot Party is the extension of what game I'm working on. So I'm working on the Dot Party, Mario Party game. And so everything's in here. Why don't I put this in, say, Dot Tools? Uh, the Game Manager Singleton probably could. The reason I don't is because a lot of when we get to like the other uh, input classes that I made, it's kind of specific, just because of the way input works. I haven't super generalized and abstracted that yet, which I definitely could. It's just it wasn't the focus of what I'm currently working on and what I currently wanted to show off in this video. So we're going to continue. So moving on, let's head over and look at some of these variables. You can notice I do delegates. I started to do delegates, but that wasn't actually the right way to do this. Um, I can share a little bit of that why after we go through some of this. So we're going to go ahead and look at protected game mode node being a mode node that I created. So the idea is that this game manager has reference to the game mode node, which is the current game mode that we're playing. We set that equal to null because it's a game object and it is nullable. And since it is nullable as a game object component, as a mono behavior, uh, because it is nullable and Unity does decent null checks, we can actually compare if it is null. So to make sure it's null explicitly is kind of nice. Same thing with manager singleton. Uh, Manager singleton, even though a lot of people do make static game managers, the reason this is not a static game manager and is not just a C# class is because I do want it to exist on the object so that it can be persistent across multiple Unity scenes. So if you think about it, if it was just a C# class, I couldn't make it a persistent object with the do not destroy on load. It could be referenced by a uh, non-destroyable object, but there's no guarantee that it won't get destroyed, even though it's referenced by one. So we just keep one with this, and we keep moving on. Game manager instance. So this is for the instance of a single object to reference. So this is our game manager, the actual object that will be created. And then we have single player input collector. So we have PI collectors. And the job of PI collectors is, hold on, that was a weird sound. Okay. PI collectors. I don't know if that picked up on stream, but there was like some weird interference on my microphone. So PI collectors, we have the player inputs that will be collected. So these are the player input objects that we get from the um, player input manager that we instantiate. And we just do a list of these because we just want to list to the references. We don't necessarily need um, anything else to this because we just want this to stay in order. We also want it to be assigned, not assigned in the inspector, but assigned by another or added to through a delegate. Huh. Okay. Through a delegate. And it kind of sounds like my headphones are haunted right now. It's like doors shutting in them for some reason. Single player input collector by integer. So this is player ranks. The idea is that they can use this integer value in any way they want via coins or via like a golf scoring system. So we add like first place gets 0 points, second place gets 2, third place gets 5, or whatever your actual scoring system would be. Um, so that that can be decided upon by the group and kind of flip back and forth and can also be changed by other classes that they have. So this one works really well. Um, this was to avoid having it so that they have to use like a very specific scoring system or way to rank players. So player ranks is just this, and then what you would actually have to do is for a display, calculate who's in first, second, third, but that's a different uh, class altogether that would handle that. We walked through the on enable kind of briefly. My tongue's kind of sticking together here. So let's look at the on enable over here. We have if an instance is not null, so that's if our object that we are is not, or if our object that we are is equal to null, then we have the instance equals this. So if I exist on enable, if the instance, the global, or not global, but the static instance is null, then it equals the instance that I am. And then get component player input manager on player joined, add on player joined. So break down this line, we look for a component, we have a player input manager, and then on player joined. So this is the component on this object of player input manager, and then we get the delegate, and to the delegate of on player joined, meaning a player has joined, then we add the method of onPlayerJoin. OnPlayerJoin defined in this class. Let's go look at onPlayerJoin real quick. OnPlayerJoin is just a player input API, takes the PI collectors and adds them, adds the API and from a player input. So this would actually be passed by the player input manager of Unity that we have on this game object. So API passed in, we get the component from the player input. We grab its single player input collector that we placed there. If you remember and we look back to our Unity, I mentioned that game mode node. We have the mode node. So in here, once the mode manager adds onto it, say here. Okay, yeah, there's construction across the hall. That's a little less creepy now that I can hear it clear. Game manager singleton. So player input manager with the game manager singleton. You can see it goes and grabs this one and adds itself to its delegate, which is its events right here. So it can kind of be illustrated this way and how it adds itself to it. So on run, this will be the delegate, and this is what we want to run. So it'll work all nice and well. So we can flip back and we can see that that initial rank. So we go with PI initial player ranks, and if the game mode is not null, so as long as we have a game mode, we get the game mode node and refresh the game info. So essentially, if we add a player input, we do the things we need for our for our game manager that is static, that is not static, but is persistent. And once we do the things that we need for the thing that we are persistent, we do the things for the thing that is local. So we do the local game mode node, which does not go from scene to scene. Report It is just a printout I have for troubleshooting, so don't worry about that. We're not even gonna really cover it. We go back to our on enable. So if we do all this stuff, that means, yay, our instance is now this object that we are. And else, we just destroy, whoops, we just destroy this object that we are. Report, again, just a quick printout of stuff. You can see here, it's just like printing my dictionary to make sure my dictionary values are right. Awesome. So init player ranks. This is just setting up initial player ranks. If I hit Control F, we can kind of see where I used that. Doesn't appear that I've used it anywhere yet. Oh, on player join, init player ranks. So it initializes the player ranks all to 0. So when you add a player, it does wipe all of the ranks. But we can also tell it not to allow it to add in certain scenes. So there's that as well. Uh, which is probably a later problem. But let's continue. So init player ranks, update player ranks. So this is simply a thing, update player ranks. It updates based on a dictionary, player input collector, and int. So you might wonder why am I using single player input collector? Input collector being the class I designed just to help manage the object that's collecting input. Well, I don't really want it to use an integer as a key. One part because then I have to have two dictionaries, one that is the current player number, and then go to player input collect, like another dictionary that's input collector by score. So this just saves a little bit of space in my brain. And then that is a player ranks. So for each key value in player ranks, so simple dictionary. If you're not familiar with dictionaries in C#, you can go ahead and look up syntax, but essentially dictionary type 1 key, type 2 value, and then for PR in a player ranks, um, player ranks PR dot key. So the key of the PR object that we're on, so that player rank object in player ranks. And then we do plus equals PR dot value. So indexing at key means we are looking at our value. So we are adding to the value found at key. Uh, that's quite easy that way. And then on player join, this is the delegate we looked at. Let's look at the singleton. This is a cool idea to understand, not necessarily need to memorize, but we have a getter. So we have a public static game manager instance with capital I. So this is our accessor for our instance variable. This style ensures that we only have one instance and that we have no other uh, singletons. So when we go to get one, if instance equal null, then we create a game object. Way we create a game object, new game object, NGO, because don't use new in a variable name, new game object. Prevent object from being destroyed on scene load. So we created the game object, we do not destroy it on load, and then we get the instance. So setting the instance equal to the ngo.gameObject.add component. So this is just looking at the game object, getting its game object property, or game object component, adding a new component, declaring the type that's we're adding is game manager singleton. Um, this could be done, these two could be done in either order. Probably makes more sense to do the instance assignment first, since we want to make sure there's an instance before we do not destroy unload. But again, not a big deal. Just something to think about. And then once we do determine what's going on, we do our instance. So this only runs if it's null. Otherwise, it just jumps straight to this line and does the return of instance. We have some accessors here too for other classes. This is just so they can access some of the information. Sometimes set, like game mode needs to set because game mode node needs to tell the singleton what mode we're actually in. So we're going to move from our game mode node to a new game mode node on enable, which we'll see later. We have the PI collectors and the get return PI collectors. And we do the same with player ranks. We can get player ranks because we want to be able to read the information of it, but we don't necessarily want to be able to change it through any kind of setter. We want our game manager to take in a dictionary and decide how to proceed, if that makes sense. So that's defined by the current or over or child of this class. So that if we inherit from this class, that class can decide what it does. Otherwise, it can just use the default thing of adding that score together. With that, which you'll notice that a lot of these are, well, these aren't. Some of them are. Some of them are protective virtual. There's actually, oh yeah, there is. The only reason they're protected is because you can inherit a protected method, which means you can mark it virtual, but you can't inherit a private method. So if I made these private, I wouldn't be able to overwrite them later. You'll notice that private ones like um, private on enable. So we have private on enable, and what does that do? That just means that we can't override this later. The which this also probably doesn't matter anymore. The only thing that really matters is that we have a private, so we can't set the instance. And actually, this can't be inherited from anyway, because as soon as you do that, this will break. So there might be a few more things to check out. This probably isn't fully ready, but as a framework, it's ready. And you'll hear me saying that a lot. How is it ready as a framework? And it's like, well, it fills out the basic needs I need for this program to function. So it's a framework. It's not a finished application. So next thing we're going to do is we're going to look at a single player input collector and understand what exactly I meant when I created that. So this sits on the object that would be a prefab that is instantiated on the join. So if we want to look at what that actually happens in the inspector with, we can look at the game object manager and we can look at its player input manager. And we can look at its this one, player prefab. So the player prefab for this guy is the single player input persistent. So let's look at that. So this is a prefab that I made. Um, if you're looking to do this later, you can right click, create prefab. It is in here, but I'm terrible at reading and finding things. Prefab. So you can do that and create a new prefab, all that sort of thing. But basically, if we're explaining this idea, we're looking at the prefab that I made, and we're looking at player input. So player input is the thing that we need to add to allow it to do input. You'll notice it has a camera, it has behavior, it has events. So I do actually use the events. Um, and we have player input, input action asset. So master player input is what I name my player input map. And uh, that as well, you can just, if you have the input system installed, you can go create input actions and go through the steps there to make your own actions. And then once you do, you can go to player input and do your default map, master player input. You can do your default. You can do your actions here, which will be that object. Looks like that with that icon once you create it. And then default map, um, player master input. You can do none. It doesn't make a huge difference depending on what scale your game is being made at. But then we go into events. So I like to make sure that I invoke Unity events so that I can use pass-throughs like vector2s and vector3s. And if we continue on, we're going to go ahead and look at, it has a couple here. So device lost, device regained, controls changed event. So we don't deal with any of that. This is a very simple framework. This is meant to be like Mario Party. It's meant gonna have like 4 buttons. Uh, well, it has a few more than that, but you can see WSAD. This is considered the four-way input, which we'll see in a minute. And primary button, secondary button, positive aux, negative aux. Um, stands for auxiliary because I was like, I was thinking in terms of like GameCube controller, we have four-way, which I'm mapping to WSAD because we're starting with keyboard or started with keyboard. I have primary button, and then I have secondary button. So this is like A, B, and then this is like X, Y. And you notice I did add a function, but we won't look at that right away. That's mapping to the input, but this is where I map to my move context, or not my context. I map to kind of my bridge, which is single player input is my bridge, and my, um, well, let's just look at it. So single player input collector has a game mode node. This is kind of deprecated, I think. I don't think I actually use that anymore, not in this class. Yeah, I mean, it's still in there. I just don't use it for anything. Anyways, little updates aside, game player node is important. The reason that's serialized, protected, um, might not be any reason it's serialized other than I could see it in the inspector then. And this is player node because what actually changes it is down in um, I think there's a get set. So there's a set for this one because a player node is going to set, no, a game mode node is going to set a player node inside this object. So we needed a set or a method that could set it. So basically we start with this node, which is going to be the player node for the game mode that we are currently on. The reason it's done this way is because if we did it where I looked at the game mode node, which was my original thought, I would then have to, in game mode node, have a list of all the nodes and then try and like figure out which one's in the array every time. And it was a whole extra layer of hassle. at least from my point of view. So we don't really use this method anymore either, but on enable, I have a method that that you might see in all of my other videos, which is collect variables, uh, sometimes called collect vars, trying to spell things out more for beginning programmers so that they can read it a bit more easily. But then we also have a transform.parent equal game manager inside collect vars. So why is this part of logic important? Well, if we transform the parent, the game manager singleton, so we are setting the parent of this game object's transform, so the game object that this component is attached to, and we're setting its parent to be the singleton instance, meaning the singular game object manager that is persistent, and we're setting the game object that that instance is attached to, um, and we're setting, and we are getting the game object component that instance is attached to. And from that game object, we are accessing its transform, which I'm reading now, and I can probably just do that because every game object has a transform. So we can also, because of the way that Unity writes its code, we can also just get the transform without getting a game object, which saves a step. Is it faster? Probably slightly. Is it more readable? Absolutely. Transform.parent game manager singleton instance transform. So now that this is actually parented to the singleton that is persistent, we don't have to add it to do not destroy on load because as a child of the parent that is do not destroy on load, we no longer have to worry about that. It'll just follow through with the game manager. And the beauty of that piece is that that input collection follows with the game manager through every scene, and the game manager takes care of seeing if we need to destroy or create a new game manager. So all of this just kind of happens automatically, which is nice. Um, we public virtual primary button press. So you're going to look at a lot of these. These are the input, and I use region to kind of put together some of my sections of code. So for this one, for instance, we have a region for input management. So this is all the input is just condensed into this region. And that's broken down into for primary gameplay buttons. So we have primary button and secondary button and four-way input. Uh, so this is thought of like thinking of WSAD and left stick. Might even put a note in there. One thing that would be really good to mention right here is just the input action. So I use the Unity input system. So using Unity input system. And by using the input system, we can then use an input action.callback context. And so this is the callback with a context that provides based on is the button pressed? Did it start getting pressed? Did it cancel? Did it let up? Different things like that. Canceled and let up. I'm not certain, but it seems that they're pretty synonymous at this point, at least functionality wise. So then we have input action callback context. So all of these take in a context and then do a certain thing. You look at player node, and if our player node is not null, then we just pass our context into the next thing. I should probably flip that over. Probably see a little bit better now. 30 minutes in, sure, we should improve the visibility of the code. Um, but essentially, looking at that, we're looking pretty good. We're moving through four-way input. So all of these, you'll notice, just go to a node if we have a node. Um, so if we don't have a node, it'll come in here and essentially do nothing. It won't care. Uh, and this is actually, this can probably be, oh, that's a debug statement. That can definitely be commented out. Doesn't do any code or doesn't do any actions. It does code, don't actions. Um, but yeah, so that's kind of that idea. So we can see our logic kind of coming through. I want my input to come. I want my input to be set up by the manager. I want my input to be managed by the manager. And then I want my input to be executed only really by the node. So this is kind of similar to like if you see a bridge pattern. Uh, I'm just kind of using the word nodes because it helps me think of the organization because I kind of think of this like a network, uh, these four classes. So you have like your um, routing, kind of like your routing, upper routing, external router, which is the game manager. And you have like your kind of like your sub networks. And then they do talk to each other across a little bit, but um, one is entirely persistent, which is kind of why I think of it as outside the network. And the others are all in network. So kind of as we're moving from network to network, we're talking to the individual nodes. Um, might just be my flawed understanding of networking, but uh, we'll move on. We have primary buttons, player node. So this is just allowing us to set what it is. This debug statement, don't want it, don't need it. Uh, this should all be good. That should all be good. I think we're pretty much following up with where we're at. I think the next thing is to go ahead and look at the game manager node, game mode node. So the game mode node, and then let's go to the scene. So why game mode node? So game mode node, if we look at it, you'll see we have an element in here that's testable game op player node. So what do we want to do with that? Well, the reason I want to do that is I want to go ahead and if we edit it, what is it actually doing? So it has a list of player nodes, right? So this is assigned in the inspector to make it easier for new programmers slash designers in Unity, probably slash designers more importantly, because then they can set up how many nodes are actually in a game mode. So we can have certain ways to track how many players are needed for a certain game, um, and then allow it to split the teams up or other things, what have you. So this is kind of that idea. So it's important to have a list of the nodes that's assignable for designers because we might also like just decide um, maybe we want to change the player count that's available and maybe instead of doing that dynamically, which might be a little hard, might be easier for him to just add nodes. Also, we can always add extra nodes and then not use them. So that's pretty cool. Camera viewport manager, CVM, camera viewport manager. This is my script that I developed for camera viewports. If you're interested in learning more about viewports, go ahead and check that video out. It's over on the bike race playlist on my YouTube channel. So, which has been up on screen for most of the video by accident. Then we have a dictionary. We have a single player input collector. which is an integer value. So key of player input collector, and then integer value, which is also player ranks. So the idea between this is we keep our own player ranks inside the player or inside the node, and then communicate what the winnings are to the outside game manager. So we look and continue, we go on enable, we have refresh game mode info. So we should probably just follow that so that I don't get too far ahead. So on enable, the first things we do, we refresh the camera viewport reference and refresh input reference. We won't just know that this does work, and this is basically in charge of just slightly tweaking the existing view management I already had. If you're interested in learning how that works, go ahead and, like I said, check out the bike race tutorial video on that. Refresh input. So the first thing I do is get a reference of the instance, the game manager singleton instance. And why do I do that right away? This is mostly so that I can go ahead and get so I can call on it, because if I don't want to retype this all the time, it's mostly laziness. I can just type GMS. And since it's a local thing, so it doesn't go outside of this method, you'll notice it's not like a class variable even. Um, so the chances of somebody missing this at the top of the class is not very high. So it's not bad. It's not as bad for readability as if this was like class or global variable. Um, it's defined right here. So then we go GMS, game mode node, this SPIC, so single player input collector, list, S for plural, SPIC for single player input collector, uh, gms.pi collectors, so collects all the input. This is the assignment. So the idea is, and that's the reason why the list never changes, it just adds to and removes from, but the list order never changes, which becomes important because I don't want the, whoops, I don't want that order to ever change, because my thinking is the new designers and stuff are going to want to assign. I mean, we'll probably need to leave notes for that as well, but it will be easier if they can just assign in order in the list which one's player 1, 2, 3, 4 for certain things. It'll just keep our input clean, uh, or at least orderly, so that those inputs are always in line. So once we get the PI collectors, right, we're each in the count while we're less than the count. So we'll never equal the count, which would be outside of our array length. If you haven't done a lot of for loops, maybe you want to check that out on the C# documentation on Microsoft. Uh, but essentially we're going to go through, and this loop is designed to assign all references to input collectors. So we take the input collectors index at the number we're on, so the index, and then we do dot player node, so we get its player node and assign the player node to be player nodes, which are, let me show that, game mode node, player nodes, which are equal to null by default. So these are assigned by the inspector, as we mentioned. If I do back arrow, come back down to this line. So according to whatever player node is in there, we assign it to the player node of the input collector. So then you think that way, now that it's assigned, the input collector can go ahead and gather it, and it can go ahead and call the methods that are in the player node. Camera equal player nodes. So this is more camera management. Don't worry about that for this demo. Um, and discussion. Let's go ahead and go if camera. Okay, so this is more camera stuff. Don't have to worry about that. Most of the camera management stuff is handled by the camera. So we just create a new one when we have to restart. That pretty much should explain that. Feel free to post any questions, either in the comments if you're watching this after, or in the chat if you're watching this live. Um, we're all good so far. I think I'm moving on to the player node. So where does the player node exist in the Unity scene? So always start with that. Much easier to visualize our code if we have a visual. So we have a testable game player node script, none. So just ignore the camera stuff. We have a player move context. You can ignore that. That's for me, for my testing. Let's go ahead and I forgot this was on. So it, well, okay, let's do this. We see where it is on the inspector, right? So let's go ahead and go to the game player node. The testable node has no different code really anymore. That was pretty much taken care of once I fixed this node. So we start off with a camera, ignore camera, move direction. So kind of think of this as the bridge, so to speak, that I did in the racer input, which is kind of where this is heading. If you've noticed, this is probably going to be used to separate my racer input from my scene to scene input, uh, which is what we're going to do live after the video. So after the recording part. So look forward to that. We have a RB, we have a rigid body set equal to null for that that null check reason. We have a player move context PMC equal null for that same null check reason. We have a on enable that does collect bars, and we have a protective virtual void collect bars defined as, and all that really happens is the get component in that one of getting the rigid body and assigning the rigid body to our RB. So that's should be pretty familiar to most Unity developers, uh, the RB at least. The PMC, player move context, um, is not really necessary. It shouldn't actually be there. Um, so if we're thinking about it, this is the bridge, right? This is where all the input goes to gather all the numbers and hold all the variable information that needs to happen. And we'll look at an example in a minute here. But if everything's stored here, all the input stored here, we have an update frame and we have a fixed update frame. And other objects can come in here and just read that information if we give it gets. So if we give it accessors for other objects to access the information, then we don't actually have to call other methods. We can have other methods call in like an update fashion or a fixed update fashion, and then they kind of define how they call for the information, how often it's called, and how the information is used. So basically what we want to do is just make sure as much as possible that our information is in terms of vector threes and a lot of force and stuff, make sure everything's normalized, make sure it's stored, make sure it's updated correctly, that sort of thing. So update correctly. Let me move down a little bit. And what do I mean by input updated correctly? Those values updated correctly. Input action callback context, ACON. So the thing is, every time the directional changes, so if you think of your joystick type or tilt forward, that's a 0, 1, a 0x, y 1. Uh, do up right, it's going to be 0.5, 0.5, or something to that effect, split between x and y, positive. Um, so those both get sent to it, but they only get sent on the down, so when the change happens, and then they get sent on the stopped or canceled and sent back to 0. So we want to make sure we have a logic that saves that info correct, like as that's happening. Reason why we want to save that as it's happening and then have other thing access it is because if you call it when that happens, you're only calling it on started and canceled, and it's not really reflecting that you're holding the input. So that's kind of why we save the vector2 out into a little piece of memory, and then we read it via some other thing on fixed update. So that's what I mean by read it correctly, store it correctly, that sort of thing. So we kind of separate, if anyone's done web development, it's kind of thinking of it, it's kind of similar to when you think about things in it's an MVC format, model view controller. You have the model, which is the essentially data. You have the controller, which controls the actions, and then you have the view, which is what you actually look at, how you display the information, um, that sort of thing. So this is kind of similar in that thought. This would be like our model, and then maybe our view, how we display the information, would be our move context that I defined later, um, which you can see how I make a move context in the other bike race videos as well. It's a little more in depth because it uses state pattern. Uh, but maybe we'll do that in a minute after the video. Uh, so in the stream video posted. Um, but for rate input, so that's essentially what I'm looking at. You'll notice that this player mode node doesn't really have anything that assigns it to something. And that's because, as we discussed, uh, game mode node did all the assignment for us um, for index in this list. It does all these things, um, or just this thing. Assign input collectors and input node. So it does that sort of thing for us, which is pretty nice. And we have a little bit of that. With that, if we look at the game player node, we're just looking at a few things. I think that pretty much covers a lot of the idea. And the way the thing we get with that is if we go to Unity, and this is kind of the demonstration. So this button, I didn't talk a lot about it, and mostly because it's not important. It's just kind of a test thing. So I just created a canvas with a button, and I made a script I put on canvas called menu navigation. And right now, I would actually build this into a real menu navigation script. Right now, it just loads next scene. It has one method, load next scene. That button calls. So I added it on click, canvas, menu navigation, next scene. And so if I hit play, you can see that, okay, we're in here. We can see our game object manager, right? Our cube exists. So that's our player node. Our so our game node, our player node is that cube. It is under the game mode node. As you can tell, I wasn't thinking a whole lot about how to pronounce these names, only on how to read them. Game mode node, which assigned or has not assigned yet, because under game management, you'll notice there's no object yet. So if we right click, which will give the input manager a join request, you'll notice that we get a single player input persist, which is the prefab that I told it to instantiate as a player prefab. If we go to console, you'll notice that the debug statements did happen, and maybe even if, let's do that again, so we get a nice clean console. So you'll notice here, it ran the first time, meaning that my game manager exists and runs. If we right click, we'll see an object appear under game management. Yep, single player input, persistent. You'll notice updates here. And this is the part that prints a little weird. I didn't expect it to print this weird, but I'm not going to spend a whole bunch of time trying to figure out how to print it better. Dictionary 2, so we have player, we have the clone single, and then we have a 0. So we have the object, which is an instance of this class, right? Or here's the name of it, single player input persistent clone, and 0. So we have 0, which is the value in there. So it's current player rank. So as we would add more players, this would automatically dynamically add them to those dictionaries and fill them out and give us playability. But as we go, and if I right click back in the window and then do my keyboard, you'll notice that indeed it does move around a little bit, which is actually defined in my, it is on my game mode node, but my movement is actually developed by my player move context. If you're interested in how to make move context and stuff, there's other videos in my racing playlist, my bike race playlist. But with that, I think that covers, unless there's any questions in chat, I think that covers our recording for today, and we'll move on to the live programming, which will probably switch to bike race. I might work on implementing this into the bike race and just editing that code a little bit to make it more resilient. So with that, we're going to go ahead and close recording. Thank you for visiting Bug Free Productions. Okay, so with recording stopped, I'm going to go ahead and put it on hold, drink some water, and probably turn volume back on as soon as that happens. So let's get this back up and get the music on for about 1 or 2 minutes. Hello. All right. Sounds like we're back. And just had to run and go grab some more water too afterwards. So we'll get the music paused and we'll head on to the next one. So, um, so anyone watching in chat, always feel free to ask questions. We're going to be moving on to a little bit of different edit um editing techniques here. So, um, what do I want to do here? Well, let's probably pause that. Um, Probably quick announcements before we get going too far into it is going to be going and through and doing some of my uh, VR development sometime pretty soon here. We'll be looking at putting a tree in, but until then, let's go ahead and continue to focus on input today. I'm going to go ahead and put the holding screen back up, unfortunately, sorry. But we're going to put the holding screen up for a minute, and then I'm just going to close this and get Unity to open me a new project so we can kind of see basically what I was talking about in a little slower of a motion. I want the bike race video. Da, 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 da. I really like bike race, and we're going to continue to work on doing some of the stuff on there. I really want to release this one because I think it'd be fun, even with Sonic Racers coming out. Because it'd be cool to have like a kind of not a lesser title, but a cheaper title. I think, and hopefully we'll get some designers or something working on it soon. I just don't have money to throw at the project currently, and so we're sticking with the same assets we have, which are pretty good assets. I think it's JMO and Cartoon Bikes or something. But yeah, so we're gonna be looking at that, and hopefully we'll do some VR stuff soon. That's still launching. It's taking a little while. Sorry, but we have some stuff running, whatever runs. But yeah, so we'll look at doing like a VR tree into the classroom project I was working on. And we'll also look at doing some VR stuff uh, as a fishing game, quick kind of development, which would be kind of fun. Should be pretty fun. The other thing with that is though, VR, I'm probably not gonna be testing. It's probably gonna be a lot of scripting and then me coming back and saying if it worked or not. Because it's just way too graphically intensive for a poor master's student to be able to run. Uh, that would require like probably two graphics cards to do effectively between because it doesn't even like to run Unity and um, Unity pretty much. Unity OBS will freeze not freeze, it will lower the frame rate output in both devices. So it's pretty fun. Or not in both devices. It'll lower the frame rate in the Oculus Quest preview. So it doesn't, plus the act of taking the headset on and off while it's running is really hard on your eyes. Not as the developer, like the person putting it on and off. Uh, but in terms of the video, it like shakes a bunch at the end, so we probably won't do that style of video. Um, that's probably more of like a clips and demo type thing, which is not really the channel idea. But either way, it's just no VR stuff is coming. We'll talk about it and we'll look at it. Just won't be any live builds, is the only caveat there. So let's go ahead and look at that. If nobody's seen that shortcut before, little arrow here on our prefab, go into there. Um, quick refresh on what the heck we actually did. Byte container, biker scene, byte container, full body. Okay, so darn it. Would that be a camera? Yeah. This would probably take more refactoring actually, because I've got the camera in here. Well, no, because the player container still spawns. The player body is yep, this should all still work perfectly fine and normal. Um, we'd probably just have to change the way the input is working. So, um, maybe it would be best to go and create nah, it's fine. Anyway, move context. So instead of linking the context to the bridge, right? So if we were going to implement an input system like we were just looking at a little bit ago, how would we do that with our current setup, right? We'd probably want to look for our input bridge, which I'm having a hard time reading the screen because it's pretty far away. Racer context, racer input bridge. Here we go. So we think about it, the bridge is a pretty similar class to the one we just looked at and worked on, right? So the thing we just covered. So why is it so good? So this already does all of our storage stuff, all that sort of thing. Um, Probably already takes in all the, yep, recenter should run automatically. So anything that doesn't have a parameter can be run automatically. Cool, cool. Move input, all of this is already public and virtual. That's all good. So basically we shouldn't have to do anything extra except change the input node. So we'd make our input node connect to these things. Um, which means our player node would probably look a little bit different. Um, and since none of these guys do anything until enable, that would all pretty much work out. So we're thinking about it, we can pretty easily move this to be more like that other system. Um, we just have to think how we're connecting the player collection input, like input collection, into how do we attach it to a game mode node, um, which would probably be in the prefab. So we just put it on the container level probably, or would we? Because we can already get the player input, so wouldn't really have to. Um, so the idea is that we have another object in the hierarchy. That would be our game mode. Game mode node. And he'll probably have a game mode node. And why does this have a game mode node script on it? Because this is going to be basically our game mode node. Um, and if we edit scripts, basically to make it a game mode node. Let's go ahead and put it in the bug-free racer right away. Um, Control RR. Racer game mode node. Let's do R. Let's go up here and do our comments first. Slash, and then we're gonna go ahead and we're gonna move on to the 628. Up, up. So tired. We're gonna move on to go ahead to namespace. Like Productions dot arcade racer. Let's actually once we add the brackets to that, let's go ahead and rename this one again. Arcade Racer. So Arcade Racer game mode node, uh, mono behavior. What's the reason for this mode node in particular? Well, it's going to need a list, arcade game mode node. Actually, there's a couple that we should probably look at before we get too far into this. Um, that's because we've already kind of started the groundwork in previous videos and stuff. So let's go ahead and look at them. And I'm probably going to run this for, we'll probably stay on almost an hour 30 right now. So I'll probably stay on until I get a decent chunk of stuff done, and then I'll probably sign off. So it'll probably be somewhere after the 2 hour mark. I want to do a little bit of work in this game because I really like it, and I really like the idea. So I might have to throw. Let me throw the holding up for one more second. Let me get this down on this screen, and this opened on that screen. Cool. And then we can pull the hold back off. Okay. I just don't want to, I want to show my paths as little as possible. So I'm just going to open my Show and Explore. And then if I look through my other stuff on this document tab, I want Mario Parties, assets, scripts, just so I can open them up and look at them as I go. Race checkpoint. So lap tracker should be perfect. Fine. Trigger CMD client. We probably still want to look at a couple things um, in terms of this, right? Or in terms of we have a game manager, so we want to check out what that looks like before we get too far into it. I want cancel gravity search. I want management basically. Game mode. Okay, so you can see I probably already started it a little bit here. Singleton Race Manager. Private Void Awake. Not great. Um, Why is it awake? Don't know why it's on awake. Might be because I hadn't started doing on enable for everything yet. On enable. Let's try and run it with that. Let's try and run that with that. Unless it totally breaks. I don't even think the game manager has anything running yet. The camera's kind of wacky, but okay. So the bike still mostly works. It's still got some issues with the camera, which I've learned some ways to deal with that a little bit better. Part of this issue is being with the tilt and the look too. So once we deal with that, there's some more camera work to be done, but some of that can be done with scriptable objects. That's not our point, our goal right now. We want to look at our player manager. So what's our player manager look like? Player manager is a mono behavior. This is set up specifically for doing camera viewport management stuff. Um, on enable. So this was specifically designed just to manage the players as they add themselves in. Single race player manager. This should all be fine. Um, you're seeing now where it should probably just be replaced with the other system, at least for the top two classes. So, because that would allow us to basically not have to deal with those other two classes, but they're not even in this scene, so they're not actually being used right now anyway. So they're not necessarily needing to be altered. Let's go ahead and think where our game mode node would need to be. So our game mode node would be here. This would be our game mode manager. So what's our game manager currently look like? It is a singleton, correct? It is a mono behavior. It does the instance thing. On destroy, instance is null. Instance does this thing. Um, add component game manager, do not destroy unload instance. Race manager. So the one idea was that we had was to add our player inputs to a manager, right? So we could still do that. Race manager would be replaced with some kind of game mode node manager, um, which we would then edit race manager to fit more like a game mode style, placed by racers. Okay, this is fine. So this is essentially the ranks that we had in the game mode node. I mean, in the game manager over on the other application. You can kind of see where some of that was abstracted from and simplified a little bit. Um, game mode node instance, game manager, add component, obj. I'll check my thing here. Don't destroy unload. So all of this should be pretty good. The idea next thing would be to add our player or racer input manager or player input manager. So let's go ahead and use Unity using Unity Unity engine. No, engine dot input system, and it's going to use player input manager. We're going to continue with private on this. Um, private. Um, player input manager. Player input manager equal to null. Do we need to save this reference? Possibly not, but we'll set it up for if we are going to. This is all stuff afterwards. We don't really need to worry about regions because we don't have a crap ton of methods yet. So let's do it on ABLE on enable. We'll make a method called collect. Variables, parameters none. I've tried to start all of my comments that aren't section headers, like methods, with lowercase. Uh, I found that kind of helps a little bit, at least for me, to quickly skim for section headers and for um, for notes and differentiate between the two. Another one I would do is possibly replace methods with a region and not use a comment in that spot. Personal preference. Collects variables. Collect variables. On just so we have a little idea of when to call it, when it's called. Uh, ELES variables, didn't give it anything. Um, protected, virtual, void, variables. Kind of wonder. I'm not going to test it now, but an idea that I did just have. What if instead of making it private, it was a protected instance? Then they could inherit it. That way you could actually inherit singleton um, type of pattern, but you aren't stuck. Or I think I tried that. What happens if I put this word in there? Not, oh, it wasn't this keyword it had a problem with. Yep, that's the keyword it has a problem with. And that's because it's not a method. But if I did just have protected instance, that's a thought. Okay, not gonna do it right now, but it's a thought. So doing a protected static variable is perfectly fine, and doing protected static, so then we could have like our whole singleton all set up and just simply inherit from it, which means I could actually just pull that other game mode in and make it protected and use it as a tool rather than that. But given how much specialized code is in here, I think I'm gonna err on the side of caution and collect bars. So we're collecting variables, and probably actually what I would want to do this on is something like set defaults. Again, that's just my describe method. Um, and why would I choose that over? Why would I choose to set defaults instead of that? Well, because I don't, like I said, I don't actually want to store this. Um, I actually want to probably just copy the type so that I have the type spelled correctly. Uh, go into here and set the defaults and say get component player input manager. Um, dot on player joins plus equal our on player join player manager. Is this also a singleton or is this just rough, ready-made. I think it's just roughly made. The single race player manager. That's in player manager. Destroy p.game object. P is each player manager in PMS. Oh, this probably needs some refactoring and just pull in some other code. Yeah, this is can definitely see the difference in experience levels when I wrote this. It's pretty similar, but if you look at the player count, increasing the player count versus I don't deal with that at all anymore. So right here, player manager is doing player count. Where is player count ever even used? There's probably just a lot of code cleanup that has to happen here. Add player count. So we add player count transform players. Dictionary of int versus transform. So we're doing this type of thing. Yeah, you can see this as a little more, lots of numbers, lots of displaying, lots of extra fields. Yeah, I think a lot of this is just going to come down to me coming in here and replacing it. Passing a cam add pool, because this hasn't changed, really. I didn't change this at all, honestly. Okay, yeah, I don't know. Maybe it won't be that long. Maybe I'll just have to take some time and get rid of some of this stuff. Um, because it's looking very much like I can't add a whole lot to this building. We'd have to pretty much delete a lot of stuff in here. Game manager, model behavior. Because if we look at the game manager instance, race manager is fine, but at the same time not. So this would be better to have in some sort of setup like similar to the game node, where you just got enter and find it, right? So on awake, that's kind of why none of this ever works. So we're because we can reach checkpoint and stuff like that. Like the checkpoint stuff was getting ready to start, but didn't start race manager equals this. Okay, so it is assigning, get rid of awake, let's get rid of that. Okay, so it was assigning similar to the other one. So that's good. Single race manager, that we don't really need this anymore because this is for if it was a singleton. Some of this code is kind of old and I have to probably delete a lot of it. Prepare race, fine. So racer start positions are a list of transforms. Racer checkpoints is also a list of race checkpoints, which are actually on trigger types. So then we have dictionary transform race checkpoints, which we just left commented because we might still use it later. Usable dictionary for one last every lap. Race checkpoint bool, so bool checkpoints by racers. So every checkpoint per racer, the dictionary that goes by lap tracker, by dictionary, by race checkpoint. So lap tracker, based on the lap tracker that hits something, we go and we check its dictionary, and its dictionary we set the race checkpoint to bool. So true or false, has it been through there? Which essentially led to a really convoluted loop. Um, can we avoid that? Because we need to make sure it passes each checkpoint. Um, so checkpoint and bool are necessary. By lap tracker is probably also necessary. So unfortunately, it is necessary to check laps in that order. Um, which finish lap is what happens when you hit a lap tracker and it goes bing. Check the lap. Does it work? Cool. Um, hmm. Increment tracked lap. Okay, so all of those should be fine. The lap logic should be separate. This is on enable setting the race manager in the game manager instance equal to this. So this should be working correctly, or it should be similar. Racer input bridge. Game manager really doesn't need that. Why was single race in here? It wasn't in here. Single race manager was in the other one, which was managing to make a singleton, but we decided not to do a singleton because that would not make any sense currently. Let's just leave it loose and we'll fine tune it in when it gets workable. Placed by racers. Racer lap tracker by an integer, the lap tracker, and then its rank essentially. Racer lap trackers in game manager. Lap tracker is the racers. I think that's mostly so that um I think most of that is just so that we can do the setup. Um, and then this only accepts one race manager, which This is kind of shouldn't be done here. Whoop. Should just shift tab that over. Instance. Okay, so this is becoming do not destroy on load. It's perfectly fine. Um, on enable. So on enable, we kind of need to do the whole if check is not done yet. So I'll probably do that in set defaults. Singleton. And then this will be if instance is equal null, then we're going to instance equal this. Don't destroy on load. This game objects. Else destroy game objects. So if it's not destroyed, then we want to go ahead and get our component. Player joins. Player joins, and we want our method. Player joins. We don't use since we're adding it as delegated method. Method to run on player joined. And then we have player joined, so then we can save that. We're gonna go ahead and go on protected. On player joins. Virtual needs type. Void needs a parameter. Player input API. All right, which then brings us to, so that part's done, making it similar to the other thing. Oh, next part would be to go ahead and create our other class. So this goes a little bit slower. So you'll notice a lot of what I just talked over, I'm going through a little bit slower now. Game manager, these are in scripts game management. And do I want this in game management or do I want this in player management type stuff? Racer manager, body swap, camera, factory. I think I'm gonna leave it in game management. Um, so this is gonna be on player add. We're going to do a player create C# player. I'm gonna call it the same thing actually. Single player input collector. And actually, since we're kind of verifying that everything would work exactly the same for a good chunk of games, I'll probably go back and change the namespace of the other one to be tools so that it can just go into like a tools bin. Um, and that Mario Party will actually probably turn into more like a tools folder than it will a game, but we'll see how it goes. And my voice is starting to go, so um, yeah, might go till 2 o'clock and then just kind of fade out into the wilds. Is this a mono behavior? This is still a mono behavior. Ouch. So what was the deal with this one? Isaac Vested. Then we're gonna go into something like a God, I can't read. Yeah, probably gonna take a short rest and then work on animation stuff after. Or programming. I haven't quite decided yet. Do 2025. We're never sure how old the code's gonna end up looking. I look at what I did before. 2024, 2024. All right, I don't know where I typed the 25 earlier, but whatever. Single player input collector, game mode node class. Okay. Anyway, single player input collector. Um, bars. PHODS. Accessors. The unfortunate thing is a state machine you can never really reuse truly because it's kind of dependent on what your gameplay is going to be. But a lot of this like scene management stuff can be pretty prototyped and just dropped in. Um, Single player input collector. Hmm, bars. So what if we look at the single player input collector bars? Um, Bars, methods. What can we do here? So input collector doesn't need anything for input. It kind of needed a input node, right? So it needed a player input node. And in this case, it's already got a name. It's called a player input bridge. Whoops. player input, is it racer input bridge? Bike racer input bridge. What is the difference between a bike racer input bridge and a racer input bridge? Can we verify what that difference is? Bike racer input bridge. Public override move input action callback context. Let's go ahead and open that up and see what's our deal here. Vehicle can turn. Okay. Is it that I added that float that shouldn't be used anyway? Go racer input bridge. On enable. Looks more like it was. Looks more like it was just a override of the input. Go ahead and check our Unity and make sure. This one just uses a racer input bridge. Bike racer input bridge, which means I'm probably not using bike racer input bridge, I'm just using racer input bridge. So if I'm only using the racer one, um, then I don't need bike. So then I should use my regular racer input bridge type. Um, Racer input bridge equal, and let's make sure this has a protection level of protected equal null for default, which would be nice. Then if we're doing null, what can we do here? So if this is null, methods is probably going to need an on enable, protected virtual void. BLE. Single player input collector. Would it need a racer input bridge? No, it wouldn't. Not sure what it needs on enable right away. Probably nothing. Probably needs an additional variable, and that's going to be more like What would an additional variable here be? Additional variable probably be something like, what do you think? We need racer input bridge. We have that. Yeah, that's be fine. We are parenting. Do we want to do the parent in the the game manager like we did before, or do we want to do it here? I'm partial to doing it here, but I also don't like when, like, if there's a parenting thing, I'd rather do it by the parent and pull it in. But I would do it here and assign it to it. So we have to pass more references. Um, which seems kind of excessive when somebody already has all the information. So let's go ahead and go to be the game manager. And this is on player joins API. API dot get component. So API dot get component. Component we want is the one we just created. So single player. And let's actually change, well, single player, because it is a player. It's not just for racers, like general racers. Let's not jump at it right now. But let's leave that that way. Let's leave that that way. So PI get component single player racer collector. This is gonna need. Oh, we need the list that we're gonna add it to. Is the lap tracker. Let's check our thing. Lap tracker on this level is lap tracker. Racer lap tracker is on this level. So it'd probably be a good idea to get that as well. Ooh, but then we also have a interesting thing. Do we need, this is all it does. Do we need this? Well, actually, what would be smarter to do is instead of removing, like cutting and pasting this into somewhere else, right? Into the player, single player input. No, not single player input. This would be the player node. Player node. So we're not even touching this yet. Uh, but we will when we go to the game mode node, which is different. Game mode manager. Where does racers get? Doesn't look like racers gets used. We scroll quickly. Where does racers get used? Oh, gray. Racers doesn't get used at this level, which makes sense. Because would this be used at this? master level, the top level, the singleton level, no, this would get used by the race manager. If we're not holding on to these guys anymore, like like that anyways, we wouldn't do this. So actually we would get racer nodes. Yeah, we'd do some racer nodes, is what we'd have that handled by. Would be handled under game mode node, which would be able to handle some of the other stuff. So we wouldn't actually do this here anymore. So let's fully delete that actually, so we have less green crap that I have to read through. We're definitely not going to use a delegate here. Not going to use a subscription type thing on this. Not going to use the bridge at this level. Not going to use settings at, actually, yes, we will. We might use that yet. So don't get rid of that line. So set defaults, we do that. Else unjoined adds our onJoin event. Onjoined, we get component input collector. So what's the thing on here? We don't have to hold reference to anything in here in the game manager, right? Sorry. Um, player join. At this point, I think I'm gonna continue to work on this off stream, and we'll just pick back up on this at some point later. Um, Next stream will probably be also not a planned time, but it'll be sometime tomorrow, and I'll have probably be looking at turning the VR projects, changing the input for the design pattern in that one from a pure abstract factory into an abstract factory tree. So which we'll just be adding some tree functionality into the abstract factory so that I can make my scriptable objects a little more easily used versus what we're at right now, where there's too many of them to manage by a single designer. Um, so we'll do that and we'll see you then. Until then, thank you for visiting Bug Free Productions. I hope you found some of this useful. Remember to check out the YouTube and the Twitch videos. You can check out the bike race for anything Unity that you might have missed up till this point, and a couple other ones. We also have some Blender video, well, one Blender video, and I'll probably have another Blender video soon this summer, hopefully before August. So um, with that, I think we're good, and have a bug-free day.